Hello everybody, today we will learn few special parallelograms like rhombus, rectangle and square. So these all are special parallelograms. Let us see what is the speciality about all these parallelograms. First we will learn about the rhombus. Now rhombus is a parallelogram with equal sides. So it is a parallelogram with equal sides. Now let us say this is a parallelogram. We have already learned parallelogram. So all these opposite sides are equal. Opposite sides are parallel as well. But in rhombus we have all four sides are equal. So if it is A, B, C, D, generally we try to label in anti-clockwise or clockwise directions. Right? So it's a good habit to name A, B, C, D rather than if you name it as A, B and C, D. You can label the vertices like this also, but it is a good habit to label it in clockwise direction. So clockwise or anti-clockwise, so label it A, B, C, D, right? So rhombus is a parallelogram with equal sides. Now the property of the rhombus is that the diagonals of a rhombus meet at 90 degrees. So again we will draw the rhombus. So rhombus is a parallelogram with equal sides, and let us say we will draw the diagonals like this. So the property says that the diagonals of a rhombus meet at 90 degree or they are perpendicular. So this is a sign of perpendicular, or 90 degree means these two angles or four angles are of 90 degrees, right? So we will prove this property. A, B, C, D, so it has equal lengths. All four sides of a rhombus are equal. Let us consider this midpoint as O. Now consider triangle AOD and AOB. So I will shade these two triangles which we are considering, this and this one, right? You have to consider AOD and triangle AOB. Now see, in these two triangles, side AD is equal to side AB because it is a rhombus with equal sides. First. Second thing, side AO is equal to side AO. So AO side is, you can say, common, right? And in a parallelogram we have already studied that diagonals bisect each other. Bisect each other means DO, in a parallelogram DO will be equal to OB because diagonals bisect each other. So with the property of a parallelogram, because rhombus is a parallelogram, so it meets all the properties of a parallelogram. So we can write DO, side DO is equal to side OB. So because all the three sides of these two triangles are equal, so by SSS congruency condition, SSS means side, side, side. If all the three sides of two triangles are equal, that means they are congruent, or that means they are equal. Though they are, over here we can see they are the mirror images, but if I move point B to point D, if I fold this triangle AOB towards AOD, then they will superimpose on each other equally, right? So therefore AOD is congruent to AOB. So with this property we say that all the angles are these two all the angles of these two triangles are equal. So because thus we can say that angle AOD will be equal to angle AOB, right? This angle AOD will be equal to angle AOB, and because these two angles form a linear pair, right, means the summation is 180 degree. Therefore they are equal to 90 degrees, because angle AOD and angle AOB both are of 90 degree because they form a linear pair, means DOB. Why? Because angle DOB is equal to 180 degree. Therefore these two angle has to be 90. So we have proved that the diagonals of a rhombus are perpendicular to each other. Now let us look at the rectangle, which says, what is a rectangle? Now rectangle is a parallelogram with in which the with equal angles. So it is also a parallelogram, but it is with equal angles, means all the four angles of a parallelogram are of a rectangle are equal. So again, because it is a parallelogram, we will draw it like this. That doesn't look nice. We will redraw it again nicely. See. Okay. Now, because it is a parallelogram, the two opposite sides are equal, as well as two opposite sides are parallel to each other. The diagonals bisect each other. Because it is a rectangle is a parallelogram, so it will meet all the properties of a parallelogram. In addition to the properties of a parallelogram, it has one more property, that angles are equal. Angles are equal means if it is A, B, C, D, then it says that angle A is equal to angle B is equal to angle C is equal to angle D. Now because we know that rectangles are also quadrilateral, and we know that the interior, the summation of the interior of all the angles is equal to 360 degrees. We have already learned that the interior angle summation is 360 degrees in case of quadrilateral. Now because all these four angles are equal, so what is the value of all these four angles? Divided by 4, it says 90 degree. So that means angle A equal to B equal to C equal to D will be equal to 90 degrees. So this is a rectangle. We draw it like this because all the four angles, interior angles of a rectangle are 90 degrees. Now this is a rectangle. One more property is that the diagonals of a rectangle are of equal length. Why? We will see. We will draw the diagonals first. Now in the previous cases the diagonals were not equal, but in case of rectangle the diagonals AC will be equal to diagonal DB. Now we have to prove that. We will prove this property of a rectangle, that diagonals of a rectangle are equal. So what are we going to prove? Diagonals of a rectangle are equal. So consider triangle ACD and triangle, this is a sign of a triangle, DBC. I will shade the two triangles. See, you will consider ACD, this is one triangle, and consider triangle, this one. this one, see, this is also a triangle. So in these two triangles we can say that AD is equal to BC, right? Because it is a parallelogram, so opposite sides of a parallelogram are equal. First thing. Second thing, side DC is equal to side DC because it's a common side. Now the third thing which we know that about is the angle. This particular angle ACD will be equal to angle BDC. I think there is something AD, we have done AD, we have done DC. Also one more thing over here is that AC, we already have proven that diagonals of a rectangle are of equal length. We already have proven this thing. Sorry, we have to prove that the diagonals are equal. We already have proven that it is of 90 degree. The angles of a rectangle are of 90 degree. So the third thing we will write over here that angle ADC is equal to angle BCD is equal to 90 degrees. We will do this. This thing is wrong, right? So what are we going to do? With this condition, with these three conditions, we can say CAD, DC and the angle including these two sides, this angle and this angle. So with these two, this is SAS, side angle side. So with these three conditions we can say that triangle ACD is congruent to triangle DBC, and therefore we can say that side AC will be equal to side DB. Therefore we can say that the diagonals of a rectangle are equal. Diagonals are equal. Right, so again there is one more special case of a rectangle which is a square. Now square is again, it is a rectangle with again equal sides as well. So rectangle do not have the equal sides, but in square we have equal sides. So in case of square, it means it is also a parallelogram with equal sides, right? It is a parallelogram with equal angles as well, right? So it makes a special case of rectangle. So in case over here, let us say this is ABCD. So the diagonals, we will write down few properties of a square. So diagonals of a square, the diagonals is represented with AC and BD. So first of all, it is because square is a rectangle, they are of equal length. Right, because it is also a rhombus. Yes, you see, it is also a rhombus. What is a rhombus? Rhombus is a parallelogram with equal sides. Over here also, square is a parallelogram with equal sides. So it is a special case of rhombus also. So over here the diagonals intersect at 90 degree, or we can say are perpendicular to each other. And because it is a special case of rectangle, we already have done this thing, and because it is a parallelogram, so it bisect also each other. Right, this is a spelling mistake, sorry. So we all so we can prove all these three in case of square. We already have proven this before also, for the case of rectangle as well as rhombus. So in the same manner, this the diagonals with these properties can also be proven in the same way. Now one more thing which I would like to add in this video is a kite. What is a kite? It is not a parallelogram, but it is a quadrilateral, which I have not taken before, but I will teach you over here what is a quadrilateral. So quadrilateral is a special quadrilateral. Kite is a special quadrilateral with exactly two pairs of equal consecutive sides. With equal consecutive sides. Now see, we will draw kite like this because it has two equal consecutive sides. So if it is rhombus is represented with A, B, C and D, so this side will be equal to this side and AB will be equal to A, B, C. Right? So two consecutive means this consecutive means one after the other. So these two sides are equal and AB and AC sides are equal. So over here also diagonals bisect each other. This the one property of a kite is that diagonals sorry, not bisect each other, they are perpendicular to each other. So diagonals of a kite, diagonals are perpendicular. This is a sign of perpendicular to each other. How we can prove this? By taking again two triangles. So I will draw another kite. See, this is A, B, C, D. We will prove that diagonals bisect each other. So for this, first see, first thing over here I would like to add in a kite is that angle B is equal to angle D. If this side is equal to this side and this side is equal to this side, if this is a case, then angle B is equal to angle D. But angle A is not equal to angle C, right? Only angle B is equal to angle D. We will prove how. See, consider these two triangles, triangle ABC and triangle ADC. Consider these two triangles. So we can straight away say by SSS condition, see, by SSS condition, these two triangles, shaded triangles, are congruent to each other because AB is equal to AD, BC is equal to DC, whereas side AC is common. This side is common. Therefore, just by looking, we can say that these two triangles are congruent to each other. Therefore, angle B will be equal to angle D. In these two triangles, angle B will be equal to angle D. Okay, this angle will be equal to this angle and this is equal to this angle. But this whole A is not equal to C, right? Now again consider, so this is a part. If we are going to prove diagonals are perpendicular to each other, so in first part we have proven that B is equal to angle B is equal to angle D. Now again I will redraw this kite, the same kite. So this is A, B, C, D, right? I will draw the diagonals. This is BD and this is AC. Now perpendicular means we have to prove like this. We have to prove that this angle B, if this is the meeting point O, angle BOC. So what we have to prove, that angle BOC is equal to angle BOA is equal to 90 degree, right? So now consider two different triangles, right? Consider AOB, this shaded one, and AOD. Consider these two triangles. So in these two triangles, because it is a kite, this side is equal to this side. AB is equal to AD, right? Angle, oh sorry, side AO is common. Side AO is common, and diagonals also bisect each other. No, diagonals are perpendicular to each other. This side is see in this case right, this angle is also equal to this angle. Yes, so AO is equal to AO. This thing is clear. Now this was first thing, this is second thing, and the third thing is angle BAO will be equal to angle DAO. This shaded angle, this angle will be equal to this angle. Why? Because in the above thing we have already proven this thing. This angle is equal to this particular angle, because these two triangles are congruent. The shaded one are congruent to each other. So over here, this is again, see, side angle side. So side angle side, two triangles are congruent to each other. Therefore, this particular angle will be equal to this angle, and because this forms a linear pair, therefore they both angles are of 90 degrees. So we can say that they perpendiculars of a diagonals of a kite are perpendicular to each other. So in this lecture we have completed all the theory part of quadrilaterals, including rhombus, kite, square, parallelogram, right? So in the next lecture we will do some questions related to parallelogram. Till then, goodbye.